Okay, the last section of chapter 6. So as I said earlier, we start with rectangles, then we go to antiderivatives and actually do integrals through that. And now we're going back to approximations through shapes. So I don't know why the textbook is set up like this, but it just is. So another way of approximating area under a curve, the integral, is using intervals to use trapezoids instead of rectangles. So the area between a and b of under some function, fx, is going to be h over 2 of the value of the height of the first one, then the 2 times the value of the second one times 2 times the value of the third one, blah, 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 where h is equal to the upper boundary minus the lower boundary divided by however many sections you're breaking it into. Okay. So if you have something like this, here's A, here's B. Let's say for simplicity, we're doing 4 trapezoids. So this one would be like that, this one, and then that one, okay? So H in this case, or sorry, N in this case would be 4. B minus A, so let's say this is, I don't know, 4 and 2. Right, we could figure out our H value. The reason why we're doing 1 of the first one plus 2 of the second one plus 2 of the third one, right? This would be x0, x1, x2, x3, x4, which is xn, right? So we're going to do this plus 2 of this, plus 2 of this, plus 2 of this, plus 1 of that. So that's going to give you this plus this divided by 2 is going to give you the average. This plus this divided by 2 is going to give you the average. So notice how if we do these two rectangles, we get 1, 2, and 1. And then between these two, this jumps to a 2, this is a 2, this is a 1. So that's why it's just 1 of the outside ones and then 2 of the middle ones. And then we're multiplying by h, which is the distance across. And then dividing by 2, because we're always going to go a plus b divided by 2 if we want an average. So that's kind of incorporating everything in there. Okay, so there's our formula. So we're going to use the trapezoid rule with n equals 4 to approximate the value of the integral from 0 to 2 of x squared dx. So I've given us the graph. So if we're going from 0 to 2 and we're using 4 sections, we can split it like that. And so if I draw trapezoids, they're going to look kind of like that. Okay, so the first couple are easy to see there on top of it. The second couple are actually pretty accurate. Okay, what we know about this is A is equal to 0, B is equal to 2, N is going to be 4, so then H would be 2 minus 0 divided by 4, so 0.5. Okay, so we need to do the value of the function here, right? So this is the value of the function. We're plugging in that first x value. So we're going to have to do the value of the function at 0 is 0. The value of the function at 0.5 is 0.25. Value of the function at 1 is 1. The value of the function at 1.5 is 2.25. And then the value of the function at 2 is 4. Okay. So what this is going to look like is going to be, by using the formula, we're going to get the integral from 0 to 2 of x squared dx is equal to h, I guess I'm not going to write the formula, I'm going to run out of room. So 0.5, that's h divided by 2, times 0 plus 2 times 2.25 plus 2 times 1 plus 2 times 2. Oh, this one should have been a 0.25. This one's the 2.25 plus 4. Okay, so when we do that, we're going to get 2.875. To confirm that this works, we could actually use the area of the 4 trapezoids. So we could figure out okay, so the area of 4 trapezoids, if we want to do it that way, we can check what we just did. So the first trapezoid would be this distance across the bottom, so the 0.5, times the average of this point and this point. So that would be 0 plus 0.25 divided by 2. And then the second trapezoid would be the 0.5, the 0.25 plus the 1 divided by 2. Third trapezoid would be the 0.5 and then 1 plus 2.25, so 1 plus 2.25 divided by 2. And then the last one would be 0.5, 2.25 is that starting point, and then 4, and we want the average of that, right? So this is width times height for all of them. So if we look at the similarities between these two, notice how we have 0.5 divided by 2 times 0.25 twice, right? And then 0.5 divided by 2 times 1 twice. So here's 1, here's 1. So we can see the similarities, and that makes sense because this is the exact same answer. Okay, so a little bit easier than doing the area of all 4 trapezoids is to use that formula. Is the estimate high or low in this case? If we look at the graph, notice how the line of the trapezoid is lying above that line. Okay, it's harder to tell up here, but down here it's very obvious. So the estimate is high because the lines to create the trapezoids are above the curve. So we can calculate the exact answer on our calculator. So we can use the function of integration, which you guys have been doing. From that, we get 2.6 repeated. The other way that we have not done yet, so if we go in and we graph x squared, if we do second calc, so just like we do to find all of the other things, notice how we have the integral of f of x dx. So if we pick that one, we want to tell it the lower limit. So the lower limit is 0. The upper limit is 2. So lower limit 0, upper limit 2. And then it kind of shades in all of that area. We get the integral from f of x dx is equal to 2.6, repeating again. So those two answers, either way we want to do it, is the same deal, okay? So we'll use this to practice one. So we're going to use the trapezoid rule with n equals 4, so 4 rectangles, to determine the approximate value of the integral from 0 to 4 of root x dx. So here's 0 to 4, so we're trying to find that area. If we're dividing this into 4 bits, those are nice easy things. And then when we draw the trapezoids, it's going to look like that. So we can see that this approximation is going to be lower than the real one, okay? So I think the easiest way to do this is to set up a little chart and say, okay, my first value that I care about is x equals 0, then 1, then 2, then 3, then 4. And then the value of f of x at those spots. So the value of root x is 0, value of root 1 is 0, value of root 2 is root 2, so 1.414, value of root 3 is 1.732, and then the value of root 4 is 2. Okay, we know our a is 0, our b is 4, not 2. Our n is 4, so then our h is 4 minus 0 over 4. So our h is 1 in this case. So then the integral from 0 to 4 of root x dx, as shown by the area of the trapezoids, is going to be, we're going to use that formula. So h1 divided by 2 of the first value times 2 of the second value plus 2 of the third value plus 2 of the fourth value plus the last value. And when we do that, we get 5.146. Is that estimate high or low? Low this time, right? The lines are below. If we want to calculate the exact answer, okay, we can just plug that into the function of integration, or we could do y1 equals root x, and then go second calc 7 and plug in all the information. Okay, either way, we should get an area of 5.3 units. The last thing for today is Simpson's rule. So this is just another way to approximate an area. So this is just a more accurate representation. We're not going to go over where the formula comes from, but you guys will be given the formula. So this should be in your booklets. So this is just a closer approximation. So instead of dividing by 2, we're dividing by 3, and then we're going 1, 4, 2, 4, 2, 4, 2, 4, blah, 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 to 1, okay? So how this is going to look is if we're going to do from 0 to 2 of x squared, these are the values from the previous example, right? So those are coming from that front page there. So we had x and then the function x, right? So we had 0, 0.5, 1, 1.5, and 2. And then those things squared are those, okay? So then Simpson's rule usually is a capital S with little ticks on the end. Think of like the sans or whatever, the font. I don't know what the fonts are. In this case, remember A is 2, or sorry, A is 0, B is 2, N is 4. So then H is 0.5 in that formula. Okay, so we'd go 0.5 divided by 3. And then the value of the function of the first x, so 0, plus 4 times 0.25 plus 2 times 1 plus 4 times 2.25 plus 4. Okay, so we go just 1, 4, 2, 4. And if there was more, we would just keep going between that 2, 4, 2, 4 category, and then always just the last one. So this is going to give us 2.6 repeating, which is what the actual thing was when we did the integral. So that's obviously closer than the trapezoid. For this one, again, these ones were on the previous page, we used n equals 4, right? So we split it into 4 bits. We got 0, 1, 1.414, 1.7 something something, 732, and then 2. Okay, so then the Simpson's rule for this one would be 1 divided by 3. Remember, therefore, h is 1 because a is 0, b is 4. So then we'd have 0 plus 4 times 1 plus 2 times 1.414 plus 4 times 1.732 plus 2. And when we do that, we get 5.3 252, okay, which is really close to that actual area. I couldn't see that, which is really close to that actual area that you guys were looking at, so that's good. That is all of the content from chapter 6. So we will review any questions you guys have tomorrow, and then you guys will have a quiz. For now, you guys should be doing page 316, number 3, 4, 12, 15, 16, 33, and 34. Okay, so let me know if you have any questions.